everyone, I'm Hannah. I'm a tutor at Sky Academy. In this video, we are looking at the Year 12 Standard Maths topic of measurement. Specifically, we're looking at a non-right angled trig, MSM6, and this is our 7th video in this topic, and we're looking at the cosine rule. So in our previous video, number 6, we talked about the sine rule, where it's sine A over A sine B over B for an angle, and then A over sine A equals B over sine B for a side. This is called the sine rule because we are using sine. In the cosine rule, it's called the cosine rule because we are using cos, as you can see, cos. So that's one difference between the cosine rule and the sine rule. In the sine rule, however, another difference is you use either 2 angles and 1 side, or 2 sides and 1 angle. In the cosine rule, to find a side, you will use 2 sides and an included angle, and to find an angle, you use 3 sides. So there's the difference. The difference between them is using sine and then cos, and then the other difference is what values you will use in your equations. So let's have a look here. There's 3 examples for each to find a side and to find an angle. That's just because they're rearranged differently. I am going to use the last one in these, or the one that is highlighted in yellow, because this is the one that will be on your reference sheet. So I like to use the ones that are on the reference sheet, because if you get into the HSC and there's this cosine rule that you've never seen before, that's just because you used a different one and not the one that is on the reference sheet. So hopefully that explains the difference between the sine and the cosines rules. It's just because in the cosine, you'll have either 2 angles and 1 side, or 2 sides and 1 angle. And then in cosine, you'll have either 3 sides to find an angle, or 2 sides and an angle to find another side. So let's have a look. Here is the reference sheet. This is a screenshot I took from the reference sheet from the New South Wales Education Standards Authority website. We know that the first formula they have here is for SOHCAHTOA. We know the second one is for the area of a triangle. We know the third one is the sine rule. This fourth one here is the cosine rule for a side. And the 5th one here is cosine rule, but for an angle. Whoops, that was not, there we go. And this one here, the sine rule, is for the side. If you wanted to find an angle using the sine rule, you would just flip the other way, so sine A is on top of A. So let's have a look at some examples now using either the cosine side or cosine angle. Just wait for my computer to load. Here we go. So we have to find the value of x, which is a side, in each of these triangles correct to 1 decimal place. Now, first thing I'm going to do is write down our formula. We know that if we're trying to find a side, we're going to use the cosine formula, c squared equals a squared plus b squared minus 2ab cos c. Now, automatically, I can see something wrong or different from the diagram to my equation. My equation is using angle C or cos C. Whereas if I look here, the only angle I have is angle A. So first thing I'm going to do is relabel my diagram to match my equation. If you don't want to relabel your diagram, it just means you have to use or rearrange your formula to match the diagram. But I'm rearranging the diagram to match my formula. So I know that my angle has to be angle C. So I'm going to make this angle here, instead of being angle A, I'm going to change it to angle C, which means this is now side C. And that means that this here is now angle A, and this can be side A, and this is angle B, and this can be side B. So I was just changing them to match my formula, because I know that I need to find C squared. So I need to find C, which is X, and I need angle C to be in my diagram. So now I need to check that I have two sides, because this is what the cosine rule is, two sides and included angle. And I have one side B worth 18 and one side A worth 15, and an angle included or in between both my sides. So I can use this formula to calculate the side C. So now I'm just going to go ahead and sub these values into my equation. So C squared is what I'm trying to find, so I'm going to leave that as C squared. A squared, I'm going to put 15 squared. B is going to change to 18 squared minus, and now I'm going to put brackets around these so it's easier when I calculate them. 2 times 15 times 18 times cos, and it's 73. Now I've done that, I can go and solve for C squared. So I'm going to put 15 squared plus 18 squared minus bracket, 2 times 15 times 18 bracket times cos 73 bracket, and that's going to give me a value of 391.11. And now I've got an answer, but it's not my final answer, because I need to find just plain C. This is C squared, so it's not plain C yet. So I have to take this square and put it to a square root, because you remember when you take something from one side to the other side, you do the opposite. So I'm going to get C, and I'm going to square root 391 to get just C. And when I do that, I will get, I'm going to square root my answer, and I should end up with 19.77, but because it's to one decimal place, I'm going to round up to 19.8 centimeters. So that's how you use the cosine rule to find a missing side. First, you check, you write down your formula, and then you check that your formula and your triangle are in the same terms. So if your angle is not cos C and the opposite side being C that you need to find, you need to rearrange it to match your formula, or change your formula to match your diagram. Once you've done that, check that you have your two sides and your included angle. Once you've done that, sub the information from your diagram into your formula and solve for C. Not C squared, we want C. Let's have a look at the next example. Here we have another triangle where we have to find the value of angle theta correct to one decimal place. So first thing I'm going to do is write down the cosine rule for an angle. And it is on your reference sheet, but it is cos C equals a squared plus b squared minus c squared over 2ab. Now I need to check that I have 3 sides, 1, 2, and 3. And now I'm going to go ahead, and this time you just have to make sure that your theta is your cos c. So x is now going to become my angle c, because you're trying to find that angle. So it's got to be cos c, and the opposite side here is going to be side c. And then it doesn't matter which one's A or B, just as long as you've got C correct. So I'm going to make that angle A, this angle B, which means this side A and this side B. Now I've done that, I've got to check that I have 3 sides. Do I have 3 sides? 11, 8, and 12. Yep. So that is all good. And now I can go and sub this information into my formula. So cos C is unknown. It's what I'm trying to find. I'm going to make it cos theta to work with my triangle. A is 12 squared plus 11 squared minus C squared over 2 times 12 times 11. Once I've done that, I can then put it into my calculator and solve for it. However, we're solving to find an angle. And when you need to find an angle, you have to press shift. And so we're going to press shift cos. I'm just going to write that down. Press shift. And so we're going to press shift cos, and it's going to come up with cos -1. And then we can put our formula into the calculator. There we go, and that is going to give us our answer. You have to remember to press cos, shift cos, otherwise you won't get an answer. We have to press shift because we're going from 3 side values to an angle value, and so they're different. So you need to press shift to transform the side values into an angle value. So we're going to go ahead and do that, and we get 12 squared plus 11 squared minus 8 squared, 2 times 12 times 11. And when you do that, you should get a value of 40.4 to 1 decimal place.